All right, I'm going to continue solving this review, starting with question number 21, and we'll see how far we get. I'm going to try and make it through number 30 here. Number 21 says solve 8 to the power of 6n plus 8 equals 4,096. Now, when you're solving these, what you really want to do is get the two bases to be the same so that you can set the exponents equal to each other. So I'm looking at the powers of 8. And I see that 8 to the 4th power is 4,096. So I'm going to change this. I'm going to make this 8 to the power of 6n plus 8 equals 8 to the power of 4, because that's 4,096. Now, because the bases are equal to each other, I can set the exponents equal to each other. 6n plus 8 equals 4. And then subtract 8 and divide by 6, and you're left with n equals negative 2 over 3, because negative 4 divided by 6 reduces to negative 2 over 3. Evaluate the logarithmic expression in number 22, log base 2 of 1 divided by 8. Well, this is just your change of base formula, just like we were doing before. So you're going to start with log of 1 over 8 divided by log of 2. And just in case you've forgotten, the reason we do this is because your calculator does not have a log base 2 button. It only has a log base 10. But using this change of base formula, you can use the calculator in base 10 to get the right answer, which we're about to do. So I'm going to do log of 1 over 8 divided by log of 2. And it'd be good if you can actually see that. So that's what it looks like when it's typed in. When I hit enter, I'm going to get negative 3, which is the correct answer. Right there. Number 23. Write the given equation in logarithmic form. Okay, so we just have to rewrite this formula a bit. And remember that the formula, if you've got log base b of y equals x, then we can convert that to y equals b to the x. So we're in this form, we want to change it to that form. So we'll start with the base, log base 7. And let's see, okay, the exponent's the x, so I want what's on the other side of the equal sign to be the y. So I'm going to write this as 1 over 2,401 equals, and that's just what's up in the exponent there, of negative 4. And that should be it. That's how you write it in logarithmic form. So we're not solving all of these. Sometimes we're just writing them. But in number 24, we are solving it. We are evaluating the logarithm. And once again, this is your change of base formula. You're going to do log 49 divided by log 7. This is just calculator work, so let's type that in. So log 49 divided by log 7 is 2. And that's the answer number 24 there. And that's it. So a lot of this is calculator work. Use technology to your advantage. 25. Expand the logarithmic expression. Okay, this is an interesting one. Let me zoom in a little bit. Log base b of the square root of 24 divided by 32, and it's number 25. The first thing we want to do is change this so that that log base b is written like this. So 24 divided by 32, and that's to the, remember that a square root is the same as a 1/2 power. Alright, so I can take that 1/2 and write it at the front of the logarithm. This is 1/2 log base b of 24 divided by 32. Now I can expand this into two logarithms. Since it's division inside the parentheses, division becomes subtraction outside the parentheses. So I'm going to take that division sign and make it a minus log of 32 and a log of 24. But since I have a 1/2 in front of the whole thing, I need to distribute that 1/2 in front of both logarithms. And that should be the simplified version. 1/2 log of 24 minus 1/2 log of 32 for 25 there. 26, write the given equation in logarithmic form. Looks like it's already in logarithmic form, so I assume that means we need to write it in exponential form. So we'll do that by starting with the base, which is 7, to the -7 power equals 1 over 823,543. And that's writing it in exponential form. It says logarithmic, but I assume it means to write it in exponential form. 27. Describe the transformation of f that results in the graph of g. So we've got f of x equals e to the power of x. We've got g of x is 3 over 5 e to the x minus 1 plus 3. So I see 1, 2, 3 transformations there. The first one is at 3/5, and that's a vertical compression by a factor of 3/5. Now that minus 1 up in the exponent is counterintuitive, so it's either left or right, and since it's minus, it means we're going to go right 1 unit. And then this plus 3 makes it go up or down, and since it's plus, it's going to go up 3 units. And that's all there is to that. The next one, 28, is solve 32 to the x minus 5 equals 16 to the x plus 1. We need to get the bases the same, and I'm looking at 32 and 16, and I'm thinking 2, because if you look at your power table, powers of 2 both have a 16 and a 32. 2 to the 4th is 16, 2 to the 5th is 32. So I'm going to change these. 2 to the 5th to the power of x minus 5 equals 2 to the 4th to the power of x plus 1. Now all I need to do is distribute those exponents to get 2 to the power of 5x minus 25 equals 2 to the power of 4x plus 4. And from here, the bases are the same, so set the exponents equal to each other. 5x minus 25 equals 4x plus 4. And subtract 4x to get x, add 25 to get 29. X equals 29 is the answer to number 28. Easy peasy. Let's talk about 29. Expand the logarithmic expression log base 3 of p divided by 5. Remember, when you're expanding, division becomes subtraction. So we're going to write 2 log base 3's separated by subtraction. One of them's got a p, the other one's got a 5. Always write the one on top first, write the one in the denominator second. Last one for this video, number 30. Find the amount of time required to double an amount at 6.34% if the interest is compounded continuously. I'm going to use this formula right here. A equals P times E to the RT. So the amount of time to double would mean, let's just pick an amount. Let's say we start at 1. So if it doubles, then it goes to 2. And so that's my A, that's my P. I've got my E, the rate, 6.34%. Divide that by 100 to get 0.0634. And I'm trying to solve for T. I need to know the amount of time. So the easiest way to do this is to, we're going to rewrite this equation. because this is just an exponential equation and we need to write it in log form. So way back over here when we wrote these two equations, it's the exact same, except here your b is an e and log base e is a natural log. So we're going to rewrite this as a logarithm, a natural log, and so it's going to be natural log of the, so let's zoom out so we can get our rules on the same page here. So log base e of y, so that's 2, equals whatever's left over here in the exponent, 0.0634 times t. So to get the t by itself, we are going to do the natural log of 2 divided by 0.0634, and from here that's calculator work. And you get 10.93 years, so you can round that how you like, 10.933 years. But don't forget your units. Alright, so that's how you do number 30. Just change of base. It's just a little bit different since instead of using logs, we're using natural logs. Same thing though. Okay, that's the last one I'm going to do in this video. If you're looking for the rest of the problems, I'm going to try and put them in the last video. Thanks for watching.